Hi, good afternoon, everyone, and thanks for coming to this session. My name is Nihar Bihani. I'm a senior product manager with Amazon Web Services, and the specific product that I work for is Amazon Cloudfront, which is a content delivery service. And I'm here today to talk to you about whole site delivery with Amazon Cloudfront. So just a quick show of hands as we get started. How many of you have heard of Amazon Cloudfront? Great, and keep your hands up if you're using Amazon Cloudfront today. All right, excellent. Great, so now that we have got a couple of stretches out of the way this afternoon, let's go ahead and get started. So quickly running through the agenda, we've got four topics to cover today in the next hour. First, we'll talk about what is whole site delivery, what does that mean, then why use Cloudfront for whole site delivery. I'll also walk through a quick demo just to show you how you can use Cloudfront for delivering an entire website. So I've got a pretty bare bones website that has dynamic and static content. I'll show you how you can fairly easily configure a whole site and deliver that via Cloudfront. And then what I'm really excited about is we have a customer here today, Stephen Evans from Toronto Star newspapers. And he will also talk about how Toronto Star uses AWS and specifically Cloudfront and Cloudfront's whole site delivery features. So before we dive into what is whole site delivery, just want to take a quick minute and talk about what is Cloudfront. So Cloudfront is a content delivery service. Cloudfront has edge locations around the world and integrates with other AWS services like EC2 and S3 to make it easy for you to deliver content with low latency and high throughput to your end users around the world. And whole site delivery is a specific use case or use of Cloudfront where we have added a number of features over the past year. So let's talk about what is whole site delivery. So I have a screenshot here of the Amazon.com homepage. And what I want to highlight here is two different types of content on this page. So the top left circle that's marked dynamic is example of personalized content. So this is, it says Jared's Amazon.com up there. This page is personalized for Jared. If I were to go to this page, it'll say Nihar's Amazon.com, so it'd be personalized for me. And then what you see towards the middle of the screen, the other circle, is the image of Modern Family, the show, and that's just a static image. And both Jared and I, when we go to this page, we see the exact same image. So the point really here is that most modern websites today have a mixture of both dynamic and static content. And typically, these websites would have an architecture that looks something like this. So you see the end users here making two different requests to download the different types of content from their browsers. So the first domain name up top, www.example.com, is for the star.php path, which represents the dynamic content on this website or on a website. And that request from the browser goes directly to the origin servers, which in this case could be an elastic load balancer with EC2 instances, or it could be a custom origin server running outside of AWS. And then the second request uses the cdn.example.com domain name and downloads the static files for this website. So you can see here star.jpg. And this request first goes to a Cloudfront edge location where the static images could be cached to deliver with low latency to the browsers. And if Cloudfront doesn't have the image at the edge location, Cloudfront can get it from the origin server, which happens to be an Amazon S3 bucket or a custom origin again. So if you look at an example, an architecture like this, which is fairly typical, the issue you really run into is when end users are going directly to your origin servers, you have to think hard about what kind of performance will your end users around the globe see when downloading dynamic content directly from your origin servers, as well as the scalability. If all of a sudden you see a spike on your website, are your origins equipped to handle that kind of a scale? So change that picture slightly, and this can have significant impact on the latency and the scalability for the dynamic portions of your website. So in this picture, you see the end users are now going to the Amazon CloudFront Edge location using the www.example.com domain name for all content on your website. So CloudFront can then go to the same Elastic Load Balancer and EC2 instances to download the PHP files, your dynamic content. So that hasn't changed from the previous picture. And CloudFront can go to the Amazon S3 bucket or a custom origin to download the JPEG, the static files. But the end users are downloading everything via CloudFront. So CloudFront can really help scale both the dynamic and the static portions of your website, as well as give you latency benefits and lower the latency for end users for your entire website and not just the static content. So when you think about an architecture like we just saw where everything is coming via the CDN edge, there are some questions that come to mind. And when I talk to customers and look at websites, I hear some of these questions that have turned into themes. And I think of some of these themes as myths. The first one is none of my HTML pages are cacheable. And when I've had customers take a look more critically at their website, what we've discovered together is that there are several pages on the website that are actually cacheable and could be cached at the edge location. And that same HTML page could be delivered to several end users. So an example of this page, or a page like that, is the search results page. So to be more specific, we're in downtown San Francisco right now. So I could go to a mobile application and search for restaurants near Moscone. Chances are there are other people around the same time of the day going to that same application and searching using the same terms. And unless the restaurants near Moscone are really dynamic and changing for every user or on a per-minute basis, you could cache that page for a few minutes or hours or maybe even up to a day and get the benefit of low latency delivery to your end users. The second myth that I come across is my HTML pages are customized, so they can't be cached. And CloudFront has actually added a couple of features over the past year to help cache customized pages, specifically cookies and query strings. Those are the common ways that developers use to customize pages on a website. And you can now have cookies or query strings be a part of the cache key for your content and cache that content at an edge location near your end users. So a specific example of the type of content which is customized but still could be cached is local weather pages. So again, going along with the same example of downtown San Francisco, if you're searching for weather for the zip code here in Moscone versus a weather report for a zip code somewhere else within the Bay Area or maybe in another city, those results under the same URL could be cached at the edge location by using a cookie or a query string that has the zip code in it. So that for the 5-minute period, let's say, that you are caching that weather results page, all the users that are trying to access the weather for that location are getting a cached version of the page. This is really helpful if you think about weather alerts or situations where you may need to scale your website really quickly. And there, CloudFront can really help you scale easily because for a sudden increase in traffic for your weather results pages. The third myth that I hear about is that my pages are personalized, and we saw an example of that with the Amazon.com homepage. So a CDN won't be useful there. And there are, that could be true, but there are several occasions where even personalized pages can be faster to deliver to end users, especially end users further away from your origin servers when CloudFront is delivering that page. So when the end users are connecting to a CloudFront location and CloudFront is getting that content from the origin server. And we'll talk specifically about some of the network and path optimizations that CloudFront has built that help deliver truly dynamic pages faster. So before we dive deep into some of those optimizations and features, I wanted to talk about a few use cases where we see lots of different customers using whole site delivery with Amazon CloudFront. News is a popular use case, and Stephen is going to talk a little bit more about that from Toronto Star and how Toronto Star is using CloudFront's whole site delivery features to deliver their entire news website. We also see use cases in the weather domain, like an example I offered, or stock quotes, or travel updates. These are all examples of dynamic data where data is updated very frequently, yet caching can help you scale and lower latency for your end users. Advertising is another one. With cookies and query strings, you can actually customize the ads that you're serving to your end users on the publisher's website. So let's dive a little bit deeper into why use CloudFront for whole site delivery. What are some of the benefits? So the key message, the key point that I'd like you to take away from this slide and this part of the presentation is to think of, or to not think of CloudFront as a niche that can only be useful to lower the latency and scale the static portions of your website. CloudFront can be used to deliver your entire website, the static and the dynamic portions of the site. And with CloudFront, your applications, if you're delivering your entire application, CloudFront can help make your applications faster, scale better, more available, easier to manage, and cost less. And we'll walk through each of these benefits and see how CloudFront can help there. So CloudFront can help make your applications faster. The way I think about it is in terms of a simple equation. Long distance plus poor network leads to slow load times. If you have a global user base, some of your users will have to travel long distances over the internet to get to your origin servers to download your website. That in itself causes longer round trip times just because of the fact that they're further away from your origin server. That combined with poor networks where networks are either not performing well or there is a higher amount of packet loss can really lead to slow load times for your website or your application. So how CloudFront helps? CloudFront helps by changing both of the input variables, and that helps change the output from slow to a fast performing website. So CloudFront helps minimize that distance that your end users need to travel, and it also helps optimize the network connection so that it's not a poor network, but it's on the other hand, it's a better, higher performing network. So specifically around short distance, CloudFront has a global network of edge locations. There are 39 edge locations around the world across 5 continents today, and we're continuously adding more edge locations. So you'll see a lot more of these in other parts of the world. And as a result of this, your end users around the globe are connecting to and terminating their TCP connections and their SSL connections to an edge location near them. And then CloudFront can either serve a cached copy of your content, whether it's static content or HTML pages, or CloudFront can use an optimized network path to go to the origin servers and fetch that content for that end user. Specifically around optimized network paths, what we've done is focused on both the path from the end user to the CloudFront edge location, as well as the path from the edge location to the origin servers. So this is just a trimmed down version of the architecture diagram that you saw earlier. But here, what I'd like to highlight is from the end users to CloudFront edge locations, there's low latency from the fact that end users are connecting to a nearby CloudFront edge location, as well as TCP optimizations such as window sizing that allow for fewer round trips to send more data and more packets to your end users from the edge location. That plus and when you combine that with the optimizations between the CloudFront edge location and the origin server, where we utilize persistent connections and closely monitor the network paths, the end result can be a better performance in downloading your dynamic content for your end users than if they were going directly to the origin servers, like you saw in that very first picture, where they were using www.example.com to go to the origin server directly. CloudFront can also help your applications scale better. So the scalability really comes from 3 different aspects. One, you can use CloudFront to easily cache your static content at the edge. That's a use case that has been there since day one, since CloudFront was launched. And that helps you scale your static content delivery and lower latency there. Second, offloading connection setup and SSL negotiation to the edge. So let the CloudFront edge location handle that heavy lifting, and then use optimized connections to go back to the origin. And third, CloudFront uses persistent connections to the origin and also collapse forwarding, where if there are a number of requests coming to an edge location at the exact same time for the same piece of content, so in case you have a spike in demand for some content on your website, CloudFront will really help you offload your origin server by collapsing those requests into a single request or very few requests back to the origin server. So you see the picture of, I'll give you a customer example. Here you see the picture on the top right of the Mars rover, Curiosity, that landed on Mars in August of 2012. And the NASA JPL, Jet Propulsion Laboratory guys, they used AWS to host the website experience for the Curiosity lander. And they used CloudFront to deliver the entire website, both the dynamic and the static portions of the website, via a single CloudFront distribution so that they could really scale as new images from Mars arrived and were stored in an S3 bucket. CloudFront was fronting that bucket and was able to scale for the end users that wanted to see those new images. CloudFront can also make your applications more available. And the way CloudFront does that is, first, CloudFront is already architected for high availability. We have 39 locations today around the world, and our architecture is designed for failure. So if there is an edge location that is out of service or not functioning correctly for whatever reason, we can turn off that location, and your end users will never see the impact because your end users get routed automatically to the next best edge location for them. So from an availability perspective, CloudFront already offers you that just by having a distributed network of redundancy and high availability. Serving cached content even when the origin is unavailable. So this is a lesser known feature, but it really helps make your website more available by serving stale content even when CloudFront can't contact the origin to get a newer copy of the content. So if you have set a 3-hour TTL, time to live, on your objects, and it's already been 3 hours, but CloudFront for some reason can't go to the origin, and the origin is unavailable, CloudFront will still continue to serve that content even though it's expired in the cache, so that at least it can keep your website available. And then we do have an availability SLA that's up on the website that you can look at. A specific customer example here would be Toronto Star, and I won't go into too much detail here because Stephen is here to talk to us about that, but he'll talk about some of the availability benefits that Toronto Star saw by using CloudFront for whole site delivery. CloudFront can help make your applications easier to manage. The ease of management comes from what's true across all of Amazon Web Services, and that's self-service sign-up, easy to get started, using the APIs or the management console. But in addition to that, what customers have told us is they don't need to write any custom code, which they've had to do with other providers. Earth Networks is an example here where Earth Networks is using CloudFront to deliver their mobile, desktop, and website applications, their weather bug applications. And when they moved to CloudFront, they said that they didn't need to write any custom code. It was super easy to get started and super easy to configure their websites to deliver their entire website. There's a great video actually out there on the CloudFront website from Andy Rosenbaum, who's the director at Earth Networks, and he goes into a lot more detail. So I'd encourage you to take a look when you have a couple of minutes. And then we have features such as multiple origins and multiple cache behaviors, and I'll show you some of that when we do the demo, that allow you to use a single domain name on your website and have all of your resources be pointed at using that domain name. That just simplifies your website architecture without you needing to change any of your backend architecture, because you can continue to use the custom origins or the dynamic origins and the static S3 buckets or static origins that you have been using, and just configure CloudFront with different rules to go to different origins based on the URL path match. Finally, CloudFront can help make your applications cost less. And a couple of key points that I'd really like to focus on here. First, CloudFront charges the same for delivering dynamic content as it does for delivering static content. And this is a really important point. There are providers out there who have put a premium in terms of price on a dynamic content delivery. And CloudFront, on the other hand, has a long history of making features available to you at the same price as static HTTP content. We did that with when we added HTTPS. HTTPS was and still is available at the same price as HTTP delivery. We also added private content, which is a feature of CloudFront that you can use to restrict who can access your content. And that feature is also available at the same price as static content delivery. We added on-demand and live streaming, and both of those features are available at the same price as static content delivery. And finally, dynamic content delivery, you get the benefit of that at the same price as static delivery. We also launched earlier this year preferential pricing for data transfer between AWS origins and CloudFront Edge locations. So if you're using S3 or EC2 origin servers, the origin fetches that CloudFront makes, that data transfer out of S3 or EC2 is priced up to 83% discount as compared to any other application on the internet or any other user making a request of S3 or EC2. So that's a preferential pricing between AWS origins and CloudFront. CloudFront is also less expensive than AWS data transfer out of S3 or EC2 for higher volumes of usage. So if you compare the public data transfer, AWS data transfer rates with CloudFront's rates available on our website, you'll notice that above 10 terabytes of delivery per month, CloudFront is actually less expensive to use. And finally, if you have a large volume of delivery per month and are able to make a minimum commitment, CloudFront does offer reserve capacity pricing as well. So at this point, let's switch over to the demo. All right, so what you see here is the AWS management console, and I'm on the CloudFront, in the CloudFront tab here. And I've created a CloudFront distribution, which is D3957. It's just a very not a very customer-friendly name, but that's a CloudFront distribution that I've created for the purpose of delivering my entire sample website. So one of the first things I did is I created a CNAME. So summit.cloudfrontdemo.com, so it's a more customer-friendly name. And I've used one of our sister services, Amazon Route 53, which is an authoritative DNS service, to configure that CNAME. And let's look at some of the origin servers that I have configured for this distribution. So I talked about being able to configure multiple origins. So in this case, I have 3 different origin servers set up here. Origin dot, origin 2 dot, and an S3 bucket for the static objects. And the way I've configured these origins is if you look at the cache behaviors tab, for star.html and star.js, these assets will be downloaded from origin 2, which is basically an EC2 instance running in AWS. Star.png is so any URL with the path that matches star.png, the origin is configured to be an S3 bucket. And then default is for everything else on this website. And there it goes to origin dot, which is actually a Beanstalk application running in AWS. And what the website does is, if you go to summit.cloudfrontdemo.com, it's a Twitter application where it pulls the top 3 trending Twitter hashtags live from the Twitter API. The example of static content here is simply the AWS logo that you see at the bottom of the page. But at the top, you can see 69 cosas sobre mi as the top trending hashtag right now on Twitter. Game Insight as the second, and RT as the third. So, this is refreshing every second. And all of this content, the Twitter feed, as well as the static content, is all coming through or summit.cloudfrontdemo.com, a single domain name with multiple origin servers configured in the backend. So what's really happening behind the scenes and why this is so interesting is all of the TCP optimizations and the persistent connections that we talked about that minimize the connection setup time that your origins have to, or that your end users really have to spend in downloading this content every second. If we just go into the Chrome developer tools here, you can see that what I'm doing here is using query strings to get the updated JSON file from the Beanstalk application with the top 3 trending hashtags. And the hashtags aren't really changing right now, but if there was a shift in the top 3 hashtags, you would see that reflected here in real time. And you could just as easily cache the results for 1 second or a few seconds at a time, so that if this were to become the most popular application right now on the internet, and if you really had to scale quickly, CloudFront could take all of that load from all of your end users, and you wouldn't have to scale the origin or the origin 2 resources that you have set up on EC2. So that's really the demo I wanted to show and talk about how we're, how easily you can set up, an entire website with both dynamic and static content and take advantage of some of the network and path optimizations as well as some of the features that we have built without actually changing your origin servers and just CloudFront do the work of fetching the dynamic and static content from those origin servers. So we'll switch back to the presentation. So I'll just skip through some of these screen tags. And at this point, I'd like to invite Stephen, who'll walk you through Toronto Star newspapers and how they're using CloudFront for whole site delivery.
Well, thanks, Nihar. It's great to be here in San Francisco, beautiful San Francisco. I consider myself the token Canadian today, so if I say a lot, you know why. Anyways, I'd really like to thank Nihar and his team for inviting me to talk about our story at the Toronto Star. We've been on a journey, and that journey has included AWS and CloudFront. So I want to start off by giving you a little bit of background about the Toronto Star, who we are and what we do. So we are the largest daily newspaper in Canada. We're focused on the Metro Toronto area, which is a population of about 5.5 million people. And we have a weekly circulation of about 2 million, so a lot of people in Toronto read the print product. The website, thestar.com, has about 3.3 million monthly unique visitors. That's according to ComScore. So it's a fairly large website. We're serving tens of millions of page views a month and serving many, many objects through CloudFront. We're a fairly small group within the Toronto Star. The Toronto Star is a large newspaper, but we're about 35 or so folks within the digital media group, and that includes about 10 technologists on my team. So we're small and focused. We really run as a startup within a larger, more established newspaper company. We have a multi-technology stack, so we have a lot of Java, a fair amount of PHP, and as well as some Ruby when I can get away with it in certain niches. So Ruby on Rails and stuff like that. Our big relaunch was of our flagship property, the star.com, on January 30th of this year. That was about a 6-month-long project. We worked very hard to hit that date, which was imposed on us, like a lot of projects. And you can see what that site looks like in this screenshot here. And we'll talk a lot more about the relaunch of that site. So to begin with, why Amazon Web Services broadly, and then we'll get into Cloudfront a little bit more. I was hired in January of 2012, and I was hired as a result of a corporate restructuring where we decided to bring technology back into the newspaper part of the media company. So I started off as the only technology person within the group. And we had the mandate to not only build a new technology team, but also to rethink our website, our content management strategy, as well as our hosting infrastructure. So the Amazon Web Services platform became part of an overall evaluation process where we looked at various options in terms of cloud hosting, looked at people like Rackspace and others, ran a short pilot phase where we ran some things within the Amazon cloud and other places, and decided to move forward with Amazon just in terms of everything you've heard around price, flexibility, capability, and so on and so forth. So at that point, we started to migrate some of our smaller sites, things like PHP-based WordPress sites, tested out EC2, load balancers, et cetera, did a little bit of work with Cloudfront, but not very much. But over 2012, we scaled that up. We tested different sites, tested different technologies, and really got comfortable with what we could do with Amazon. That culminated, as I said, in January 2013, where we relaunched the star.com within AWS. I want to give you a bit of a picture of how we're using AWS overall. So as Nihar said, Cloudfront sits in front of everything we do, both static and dynamic. This is an architecture based on the Adobe CQ5 content management platform. That's a Java-based platform. What's unusual about it is it does not use a relational database whatsoever. So it's based on a JCR, Java Content Repository, file system-based data store. And it's a multi-tier application, but not in the classic sense. So we have author servers that are used by our content editing team that replicate content out to publishers that are then cached by dispatchers. All of this is operating within the US East region of AWS. It's running within a VPC, so we have finer grain control over security. We can control security at the network level as well as at the EC2 instance level. We're using 3 different availability zones, so we have redundancy across zones and redundancy across published servers. All of that is behind a load balancer, an ELB, and that's a single origin for our Cloudfront configuration. And later on, I'll talk to you a little bit more about certain behaviors and things that we're doing to control the caching rules around static and dynamic content. So that's a picture of the architecture we're talking about here as I move forward into more detail. So more about whole site delivery. And these are some of the things that we were keeping in mind throughout our implementation and things we learned through our implementation. And I'm going to go into a lot more detail in certain areas here. So I'll give you a high-level view on this slide, and then we'll drill into things like client-side cookies and behaviors. So the first thing is cache everything possible. And as Nihar has explained, you can cache just about everything. And I'll explain that in more detail. We made a call, and you can use server-side cookies with Cloudfront. We made a call to not use any server-side cookies and move all of the cookie processing, reading, and writing to the client side so that we could maximize our caching capability. And I'll show you what that looks like with some JavaScript. You control the various rules using these behaviors. And by default, Cloudfront allows you to define 10 different behaviors. We actually asked for permission to create more behaviors. We have 19 different rules. And those rules really encapsulate the business logic around what can be cached for how long and where that content is coming from an origin perspective. It's always important to do load testing. There are some particular considerations to look at when load testing Cloudfront, and really you should speak to Amazon about best practices around doing distributed load testing. But even though you're using a CDN, you're using Cloudfront, you should still make sure you have a load testing approach. I showed you the architecture, and I pointed this out, but we're using a single origin. We could be using multiple origins, but the way our content management system works, it makes sense to point everything at a single origin with different rules for different types of content. The Adobe CQ5 platform serves both static and dynamic content from the same place. So for us, this made sense. In many cases, you'll probably want to use S3 for static content, and you'll define a different origin, a different behavior for that static content. We're in the early stages of this platform. We're planning to move to a disaster recovery approach where we can replicate most of our EC2 infrastructure and our VPC into a different region for failover in case of disaster recovery. So, and that will also leverage Cloudfront in terms of its edge caching and its scalability and availability benefits. So I'm going to try to walk you through this code a little bit, and I'll probably alternate between sides. I think I could, so I can point it out to you. But what we're doing here is actually allowing an end user to control the font size that they're able to see on an article page. So in the first area here, we're actually we're setting the font size and setting the cookie on the client side. So we're using jQuery. That's what this thing is. I'm not sure how much people are JavaScript programmers are familiar with JavaScript, but basically what we're doing here is we're setting a jQuery listener for an event around a font size change, and we're dynamically restyling the content on the page using that font size setting. The last thing we do is we actually set the cookie right from the client side to store that font size. Now, typically, what we would do is we would read this on the server side and change the styles that we're rendering from the server side. But that would bust the cache, and we don't want to bust the cache. So we're really focused on doing this all on the client side. Now I'll switch over here. So what we're doing here is simply reading that cookie and setting the style dynamically. There are many other places where we're doing this sort of thing in order to maximize our cacheability. For instance, we have a personalization and authentication service that sits next to the main star.com website called MyStar. And what that service does is it simply writes cookies to the domain, and then the client-side code on the star.com site reads those personalization settings and renders something different on the client side so that all of that code can also be cached. So, yep, you really need to think about how you're maximizing the cacheability of your pages in terms of writing cookies and dynamic content. Okay. Next, I'm going to go into behaviors, and I will point out that because I'm from Canada, I spell behaviors differently. So if you thought that was a typo, that's not a typo, and it doesn't agree with stuff that's on this page. So this is the all 19 behaviors that we defined for the star.com. And what this tries to do is it tries to capture every different scenario around the type of content you would have and how long you might want to cache it for, and whether you want to pass query strings over, and all of the various settings that you would have for the edge caching of your content. These behaviors are processed in order, so really it's sort of a regular expression match, and it'll start from the first behavior and move down to the bottom. So the 19th behavior is the default behavior, and if you don't match any of the previous behaviors, then you'll hit that default behavior. So I'll show you a few examples of what some of those behaviors look like. This is the 19th one, the default behavior. And what this says is hit the, I'll go over to this side, hit that single load balancer we have via either SSL or non-SSL. Cache the content you find for 5 minutes. And a few other settings. So our default caching is for 5 minutes. Here's the example for images. Images tend to be a bit more static on our site. So, and we have the same rule essentially for pings and GIFs and other image types. And this is a 15-minute cache, a TTL. This is an interesting one. We have, our URLs are structured around the date. So what we decided is to define different behaviors that match by year. So what we can say here, although we're only caching these for 15 minutes, we could theoretically say, and we will likely do this over time, anything before 2009 is not going to change. So cache it for hours. Why not do that? So you're going to generate even less traffic back to your origin server. And we've set this up for each year. So we could say, well, 2012, 2011, we want to cache a little less long because we might want to make updates to those articles. We may have other reasons to do that. But 2008, 2007, 2006 will cache longer. We have that level of control. Oop. There we go. So here's an example where we're actually forwarding query strings. This is our search page. So, and this is a great feature where we can cache every individual query string separately. The TTL here is shorter because we want the search to reflect all the content that's been updated, and we update content fairly frequently, so it's only a two-minute time to live. And what'll happen here is when a unique query string is detected, the query string gets passed to the origin server. The result of that query string is cached for 2 minutes. So you're still getting the benefits of that caching and that limiting the traffic to your origin server, but you're also able to pass in dynamic content. So we'll move on to some of the success metrics, some of the things that, some of the great benefits we got from moving to CloudFront and using it as a CDN. The first and really most important thing from a business and customer experience perspective is our response time before the launch and after launch. We reduced response time by about 50%, and you can see, whoop, sorry about that. You can see the day of launch here, and then a large drop in response time as measured by pingdom. So many benefits there. The customer experience is greatly improved. Benefits around search engine optimization and Google Juice is impacted by site response time. So that's been a huge benefit. Nihar mentioned this, but we've also had a huge availability benefit. We had a minor wobble on our complicated backend content system the day of launch. After the day of launch, we've had 100% uptime. So, I mean, 4 nines isn't bad anyways in terms of uptime for a website, but 100%, you can't ask for much better than that. So that's been great. Other business benefits, we've lowered our overall hosting cost, overall improved consumer experience, and I mentioned the benefit around SEO. So that's been awesome. So some of the things we learned and some of the things you should keep in mind as you move into using CloudFront and using CDNs in general. There are constraints, and you just need to understand some of those constraints. I've talked a little bit about the constraints around writing of cookies. There are other constraints. Currently, CloudFront doesn't support other HTTP verbs than GET, so you can't do a post to CloudFront today. We've had to do some creative coding to get around that constraint in terms of submitting forms and that sort of thing, so this can have an impact. CloudFront has an aggressive product roadmap, so I'm confident that at some point in the future they'll be addressing many of these constraints, but these are things that you need to work around. You still need to make sure that your origin servers are scalable and reliable. The CDN can only serve content that it can reach and can return. So you saw our architecture. We still thought long and hard about making sure we had a multiple availability zone configuration. We're still thinking hard about making sure we have a DR strategy. The CDN will help you there, but it won't solve all your problems there. you're not going to be able to spin up micro instances if you have a large website and just assume CloudFront will do all the heavy lifting for you. Yeah, thinking about reporting requirements, I would say, honestly, one of CloudFront's weaknesses today is the ability to give you a really good handle on exactly what assets are being served over time. So you don't have I'm sure you have Google Analytics and Omniture and other reporting tools in terms of consumer interaction with your website, but think about the level of detail you need in terms of reporting of CloudFront usage, and don't assume you're going to get something sophisticated directly from CloudFront at this point. You'll get the raw data, but you'll need to figure out how to visualize it, how to get reports on it, that sort of stuff. You saw that we had 19 behaviors, and that was a fair amount of work to sit down with the business and understand the way they thought about how long something could be cached and what their expectations were in terms of the consumer experience. So really, it's a process of talking to the business, analyzing their requirements, and defining the behaviors that will map to those requirements in terms of the way consumers need to interact with your website. So I think that's it for me. Thanks again for listening, and I'll hand it back to Nihar.
Thank you very much, Stephen. So just a couple of resources. That's all I wanted to point out. At the end, you can get started and learn more by going to the CloudFront website or the CloudFront detail page. That's just aws.amazon.com/CloudFront. And then we do have an upcoming office hours with our engineering team. It's virtual office hours. You can ask questions, and there'll be quite a few engineers on the CloudFront team around to answer those. So between now and then, if you have time to try out some of these CloudFront features and then come ask us questions, that URL is also available on the CloudFront page. So you can just go to the CloudFront page and sign up there. And that's really it. I wanted to thank you again for coming today and spending the afternoon here learning more about whole site delivery with CloudFront. And Stephen and I and a couple of other CloudFront folks will be here. We'll be happy to take questions. So come on up and happy to answer questions for you. Thank you.